When apparel fails under pressure, it rarely happens in a straight line. Knits, nonwovens, and laminated fabrics stretch in multiple directions at once until they reach their absolute snapping point. Accurately measuring that point is critical for the manufacturers who rely on this data to guarantee the durability of their garments. This official standard document, ISO 13938-2, provides the exact method for determining that bursting strength and distension using pneumatic or air-driven pressure. Before we even touch the machine, the standard requires an ISO 10012 compliant bursting tester. You also must ensure your fabric samples have been fully conditioned in a climate-controlled atmosphere, unless you are performing a specific wet test. The entire design of this procedure, specifically the meticulous calibration and the final mathematical corrections, is to strip away the physical resistance of the testing hardware. Doing so isolates the true limit of the fabric itself. Step 1 is configuring the apparatus. For most general fabrics, you will set up a testing area of exactly 50 square centimeters. You also need to verify that your testing diaphragm is elastic and under 2 millimeters thick. Next, we select the test specimens. This diagram from Annex A of the standard illustrates the ideal sampling method. You select test areas in a staggered diagonal line across the width of the fabric, carefully avoiding any folds, creases, or the selvage edges. Testing on a diagonal path like this prevents a single localized weave flaw or a machine direction error from skewing your entire batch of data. Now we calibrate the airflow. ISO 13938-2 requires a specific testing speed. The sample must burst between 15 and 25 seconds from the moment inflation begins. Looking at this timer graphic, 20 seconds is our target. To achieve this, you need to run a preliminary practice test. Adjust the machine's control valve to either speed up or slow down the rate of inflation until the burst consistently lands in that 15 to 25 second window. Once the timing is set, place your conditioned fabric over the diaphragm. It must lie completely flat, but in a tensionless state. Clamp it securely in the circular holder. Before applying pressure, adjust the height at burst measuring gauge to the 0 position. This tells the machine to ignore the initial resting thickness of the fabric. Tuning the time to burst and zeroing the height gauge ensures that every subsequent sample in your batch is subjected to a uniform, comparable rate of volume increase. Now, smoothly apply the air pressure. The fabric will vault into a dome. The instant the test specimen ruptures, close the main air valve. Immediately read your instruments and record 2 distinct values, the bursting pressure in kilopascals and the height at burst in millimeters. This side-by-side comparison shows our next step, quality control. You must inspect the torn fabric to identify what the standard calls a jaw break. If the fabric bursts within 2 millimeters of the clamping line, as seen on the right, you must reject that test. Keep clamping new sections and repeating the process until you record at least 5 valid, centrally located bursts. We reject jaw breaks because they indicate the metal clamping ring physically damaged the yarns. When that happens, the data reflects the clamp slicing the material, not the fabric's actual pneumatic limit. After completing 5 successful bursts, we move to a critical step that is frequently overlooked, the diaphragm correction, outlined here in section 8.5. First, calculate the arithmetic mean of the height at burst values from your 5 valid tests. Next, remove all fabric from the machine. Keeping the exact same valve settings you used during the test, inflate the bare rubber diaphragm until it reaches that specific mean height. Note the pressure required to do this. The thick rubber of the diaphragm provides its own resistance against the air. If you fail to subtract the effort it took to stretch the rubber, you will artificially inflate the reported strength of the fabric. Watch this formula build on screen to find our final answer. Take your mean total bursting pressure and subtract the diaphragm pressure we just measured. This yields the true bursting strength. Apply the standard's rounding rules to your results. Round the true bursting strength to 3 significant figures and the mean height at first to 2 significant figures. The resulting output represents the pure pneumatic resistance of the textile, completely stripped of any machine interference. This list from section 10.2 of the standard outlines exactly what to include in your final test report. You must provide the mean bursting strength and height, alongside the document reference, ISO 13938-2, and the exact test area used. You also need to explicitly log the number of valid specimens tested, the conditioning state of the fabric, and the number of tests you had to reject due to jaw breaks. Rigorous adherence to all of these precise calibration, execution, and calculation steps ensures the numbers on your report reflect reality. This precision allows global supply chains to universally trust your fabric's performance claims. Subscribe to our channel for more step-by-step breakdowns of industry testing standards.